In section 4.6, problem number 24, they give you the fraction 5m minus 4 over m squared minus 4, and they ask you to decompose this into two partial fractions. So the first thing we need to do is factor the denominator. So we see it's a difference of squares, so it factors into m minus 2 and m plus 2. And we leave the numerator alone for this part. Now, the idea behind decomposition is that we should be able to create two separate fractions that are added together, one with a denominator of m minus 2 and one with a denominator of m plus 2, that when we add them together, we would end up with this 5m minus 4 as our numerator and this as our common denominator. So what we need to figure out is what will the numerators be for this decomposition. So we'll call it A and B. Okay, so think of, I'll just draw kind of a dashed line here. Think of this as an equation similar to what we did in section 4.6 number 17, where we would want to multiply through by the least common denominator. Well, in this case, the least common denominator that we would multiply everything by in order to clear out the denominators is m minus 2 and m plus 2. So when I multiply that to this side, the m minus 2's cancel and the m plus 2's cancel, and I'm left with 5m minus 4. On this side, the m minus 2's would cancel in this fraction, leaving me with a times m plus 2. Similarly here, the m plus 2's would cancel, and I'd be left with the b and this factor of m minus 2. Okay, now here's the fun part. The fun part is now this equation has to be true for any value of m in order to make this decomposition work. So we can use an m value that zeroes these factors out, and then we'll be able to figure out what a and b are relatively easily after that. So let's start by letting m equal negative 2 and see what that gives us. Well, if m is negative 2, then that will make this set of parentheses 0, so I've got 0a. Alright, if m is negative 2 here, on the left, well, I've got 5 times negative 2, which is negative 10, minus 4, so negative 14 equals, well, we already said that this a part would be 0, and then I've got negative 2 minus 2, which is negative 4b. So if m is negative 2, I can do this division, and I see then that b must be positive 7 over 2. Alright, well, what if m were equal to positive 2? What would happen? Well, 2 times 5 is 10. 10 minus 4 is 6. And then on the right-hand side, we're plugging in 2. 2 plus 2 is 4, so I've got 4a. And then this factor zeroes out, so I have 0 b's. So now I find that a is equal to, when I divide by 4, I get 3 halves. Okay, so how do I write that? Well, I can start by writing my original rational expression, my original fraction, if you want to call it that. And I can say, oh, that's going to equal to, well, instead of writing a fraction on top of another fraction, here's what I'm going to do. I'm going to take the numerator of the a and put it in the numerator of this fraction, and the denominator of the a goes into the denominator of the associated fraction. Same idea with the b. 7 goes in the numerator where the b was, and then the 2 can get shoved down into the denominator. So that is partial fraction decomposition.